Well, hello YouTubers. Today I will show you how to set up PUMOTIC software on your computer. Well, not how to install, but how to set up the parameters for the PUMOTIC software made by Pure Logic. As you can see, there are a couple of different workflow modes that you can use. I have enabled this window to ask me every time for Exes, dark theme. I don't have check it, don't ask me anymore because this is just a demo controller that I'm working with. Click OK, it will load up the screens which are for the 4 Exes controller. As you can see up here, this software is connected to my PLCB-B1 controller. For the first time, when you buy it, you have to configure. So you go, configuration settings. You will be presented with this kind of window. I call my server CNC1, it's my first machine. This is my local host address, port, those are some infos. On the right side you can see I have chosen to work with the connected controller. If the controller is not connected, you will only have the simulator option. You can reset controller, you can change its name, description, some info about the serial number, what is the firmware version. It is connected through the Ethernet, and this is the IP address. So here you can see one server is connected on my local machine, and here we have the license manager. That will be by the end of the video. So when you've established communication with your controller, then you can go and set some more things. I usually use a router which has 3 axes, X, Y, and Z. You can rename the motors as you wish. X-axis is mapped to the X-axis motor, Y-axis to Y-axis motor, and Z-axis to Z-axis motor. That's, well, logical. At the moment, the controller is configured for everything to be on the port 1, and I don't mainly use the port 1. I will do some remapping because I have the breakout board on which my controller is connected to, so the X-axis step pin resides on the port 2. So it's gonna be port 2 pin 9, I guess. P6, not P9. That is the step direction. Sorry, it is P9. Step direction is port 2 pin 6. Enable pin is port 3 P1. Enable is common for all drivers that I use. Port 3 pin 1 and port 3 pin 1. Later on I will set up the home and limit switches. Y-axis, step pin is port 2 pin 7 and direction pin is port 2 pin 8. Z-axis is on port 3 pin 6 and direction pin is on port 3 pin 2. So the rest of the inputs are the home switches and limit switches. So for the X, it's going to be port 3 pin 13. For the Y axis, port 3 pin 12, and for the X axis, port 3 pin 11. So because I use the same switch for the home and the low limit, my home is bottom left, so it will be the same. Port 3 pin 13, port 3 pin 12, and port 3 pin 11. High limit or upper limit on the X-axis will be again the same. I'm using the same pin to connect both switches, and I don't have the lower limit on the Z-axis, as you can see, not used. So I can easily plunge to my workpiece, destroy it, break a bit, but I don't use the lower limit on the Z-axis. So you have the checkboxes here, as you can see, and the legend up there is the inverted. So is it active low or active high? My step and directions are active low, enable is active low, home pin is active low. It means it's normally closed switch, and that's it for the beginning. Now we have an interesting thing. It's called Exes. You can set up here the parameters for your motors. You see, A-axis is enabled, acceleration not quite moderate, 100 units per second square. My maximum velocity is about 3000 millimeters per minute. It's about 3 meters per minute. And the machine where I'm using this controller has 42.61 steps per millimeter per 1 unit. Could be inch. It's the belt-driven machine, so that's it. Maximum step frequency, this one is calculated by the controller. It says it's 2.131 kilohertz. And maximum frequency, stepping frequency is 100 kilohertz. Homing. In which direction are you homing? I'm homing this axis in the negative direction. And speed for searching the home switch is about 300 millimeters per minute, and backing off is 50 millimeters per minute. So you can see this value will be applied at the current coordinate homing sensor. When it's triggered, it will be 0. So when the machine backs off the limit switch by 2 millimeters, my DROs, which are here, will show 0. And also, sometimes I like to have, besides the limit switches, classic ones, to have the soft limit switched on. So my lower limit is 0, upper limit is 420 millimeters. If my G-code tries to come out of it, the program will not run, because it will say you are trying to go out of the limits. So the same goes for the y-axis and also for the z-axis. I'm not homing the z-axis in the negative direction, because when you move the z-axis up, that's plus z. And my lower limit is minus 80. Everything here is in machine coordinates. Right? There could be more axes, but this controller can control up to 6. I don't have yet the rotary axis, which could be A, so I only have 3 motors, 3 axes working. Next one is the input-output. This is something that I will set later on, but just to show you, you can configure the Estop, which pin is the Estop. You can have 2 Estops, one can be on a controller and one on a machine, or if you have a big machine, on both sides of the machine. Where is your probe connected? I'm using probing of the surface of the material. Then there are parameters for the torch height control. If you have a plasma machine and you bought the license for the plasma, you can have a stop input. You can also have a safety door, so when you open the door, machine will go somewhere predefined. It's something that you can define. Sensing for the, if there is a flame on the oxyacetylene, if you want to cut, and some more user inputs and so on. That's the input side. Output side, on the milling machines you can use 2 types of cooling, could be mist and flood. Then there are output for the torch height control, for the oxyacetylene. You have to just a little bit read the manual available online. And as you can see, I have some ports here defined for the state of the program. Is it in Estop, is it idling, or is running? It's for, 3 lights resembling semaphore, green, yellow, and red. You can also have the output is milling mode, or plasma mode, or oxy mode, active, THC, and so on. It's the user inputs. You can assign a lot of things to the inputs and outputs. All depends on your machine and your wishes. Next step is G-code. When the machine initializes, what's going to happen? Is it going to be in the modal modes are going to be rapid linear move or cancel modal motion, which I do like. I don't like the controller to remember the modal motions. The active plane is XY plane. I don't have rotaries. I'm a metric guy, so everything is millimeters, so machine well, the software is waking up, starting in metric mode. Cutter radius compensation is switched off, as you can see, disabled, because the radius compensation is done by the CAM software. My working coordinate system is the first one, G54, and you can have three motion modes: exact path, exact stop, or constant velocity. There are differences. You should read the manual. You can have it online on PUMOTIX.ru and switch to English language. It's in Russian. Distance mode absolute, so that's the way how I do I like sometimes in MDI type the exact locations where I want my cutter to be. And the center mode for the arcs, I like incremental. And that's so. Some parameters which are connected to the G-code, how the G-code will be interpreted. I have checked on to ignore the unknown G-codes. Sometimes I just want to test somebody else's program, and I like to ignore the tool change. When I do generate the code in my CAM program, I'm generating different toolpaths for each tool that I use. G-code file parameters. You can put the extensions that you like. As you can see, .cnc, .nc, .tap, .tap, .txt, .gcode, and which editor you like to use. You can use the Windows Notepad. You can use also the Notepad++, which I don't have installed. It will be later on. How do we control Spindle? Spindle control mode can be discrete and can be analog. The PLCM controllers and the breaker board, they do have the pulse width modulated output, which is 0 to 10 volts, so you can connect it to your VFD if you use VFD. I don't use VFD, I use discrete spindle, which is Cress. And as you can see, I'm controlling spindle by the relay. And I do like 5 seconds spin up and spin down the relay. And also, like when I stop the program, I like to spindle to stop. Then we have some system parameters. When you go in system parameters, you can forbid the multiple instances of the client. I have switched off to load the current module at startup, so it is asking me every time 4 axes, 5 axes, 6 axes, plasma, and so on and so on. Enable statistics. That's an interesting thing if you have a problem with your controllers and you have to send some data back to the manufacturer, which is in Russia, pure logic. Interface language is English. It can be English or Russian. It's a Russian software. And distance units can be millimeters or inches. As I told you, I am the metric guy, so everything is in millimeters. Where are the headers, the tab headers placed? They could be left, top, right, bottom. I just left it on the automatic because I use the high resolution screen. And visualization quality, well, not to put a lot of strain on the processor of the computer, quite enough to be low. You can disable toolpath visualization, so if you have a slower machine, it can help you. Surface mode. is in preview of the toolpath. You can see the surfaces, the model. Show grid or don't show. I don't like grid. It's just messing me. You can show tool path projection. It's a green cone. You can follow the toolpath, so the cone will be stationary and the toolpath will move on the screen. Show start point mark, etc., etc. And you can also choose the colors. You can choose the background, feed moves, rapids, spindle, soft limits, and the start point. Then, on the right side, you can set different shortcuts for the Exes. You have to study it a little bit. This is a video only for jogging control. You can also here add the shortcuts for your keyboard, so you can jog from the keyboard any of the Exes, as you can see. How a button to change the jog units, you will see later where it is. You can set the MPG jog mode continuous. As you see, there are some shortcuts already assigned. It's the default. Jogging X, Y, and Z, left, right, up, down, arrows, page up, page down. Move to working zero control and so on. Shortcuts for the file operations, close G-code, edit G-code, open, mainly almost as Windows. G-code navigation, as you can see. You can enter G-code manually. You can define a shortcut which will open you the NDI window. To reload, move through the G-code. Feed rate control, you can online while working change the feed rate, lower or make it higher, faster. You can control the spindle also from the keyboard. Switch on the flood for mist coolant, spindle at 100% and counterclockwise, clockwise. This is just to setting the speed, spindle on off by the relay. Machine control, machine enable, run, stop. You can write up to 10 macros that will do something that you like. Probing, you can also do some probing, make the shortcuts for the probing functions which are incorporated in the software. For the rapid rate, also, and this visualization control, so you can reset toolpath, move toolpath, everything from your keyboard if you prefer keyboard. Next one is the tool table. What is going to happen when you have to do the so-called preparation move? It's before the tool goes down. You can have the interpolation over all three axes to do the preparation move, but bear in mind this one, if you use this one, you can hit your fixtures. So straight line G0 plus Z specified feed. So you can go to the certain XY point on your work and then to lower the Z-axis. Save Z moves. You can allow save Z moves. I prefer them in the machine coordinates, and my save Z is 2 mm below home for limit switch. G92 offset, is it persistent or not? So when you switch off your controller, it will remember or it will discard the G22 offsets. And also parameters for probing. Speed for probing and the thickness of the plate or whatever you put on top of your workpiece or on your machine bed, so the software can do the probing and know exactly where the tip of the tool is. Miscellaneous. Here you can define some macros, you can enable or disable macros, and jog increments. 0.01, 0.11, 5, 10, everything here is editable, so you can edit any of these. You can see here when I click on here I can put some new values. And caching parameters, that is very useful because your G-code will be cached in the memory up to 1 megabyte. At the moment I have about 389 megabytes in cache, so you can clear it. And that's it. You did some settings, you click apply, and you will have a warning. I have the port 1 pin 1 defined multiple times. That's normal because that's how I have everything connected. Okay. Next, in the configuration, you have a tool table. Like in many other softwares, if you have the automatic tool changer, or if you have tool holders that you know that will always be at the same height when you put it in a spindle, you can define tools. I don't use it. So, next is so-called access control. As you can see, you can communicate with many of the servers at the same time. You can assign the password, but that's very advanced. License Manager. Told you that I will tell you something about it. Base setup. That's something that you have always accessible in the controllers without additional payment. So, up to 3 motors, PWM spindle control, 3 motion modes, soft limits, restore state of the next one, input-output state, that's the simple machine mode. In Machine Setup Wizard, you can import settings, axis calibration, which is still in development. I haven't tested it yet, and motion setting calculator, which is still in development. I hope that the guys from the Neurologic will fix it, will put it out soon. For the CNC pendants, as you can see, the pendants that you can use are XHC, X input gamepads, or PLCM R1 pendant. PLCR is, this one is made also by Neurologic. Toolpath preview. All options are available to you. That's the basic. G-code files. You will have the recently opened in history, unlimited G-code size. You can drag and drop directly G-code in here in G-code window. User interface As you can see, predefined screens, multiple color themes, it's light and dark, that's multiple, too. Macros to bind to buttons, and it does support touchscreen, so you can have a touchscreen monitor. General features. You can have one or unlimited motors. So one additional motor is when you have the rotational axis. Unlimited motors, it's up to 6 motors. That's how many motors the controller can drive at one moment. Rapid rate override, so you can also override the rapids, but you have to pay for it. So everything here that is written trial available, you can activate the trial and it will show you for how many working hours. So if you activate any of these now, you can activate trial and it will tell you 1 day remaining time until the feature period expires. So it's 16 hours. It means 16 hours of working. I can switch the controller now and switch it on after 5 days, and I will have that trial which is in working hours. So you can see G-code extension time calculation. It's something that is visible here. I just activated it. I still have 1 day or 16 hours. For plasma cutting, there are parameters for plasma, many of them. Oxyfuel, that's the servo mode for the cutting with the oxyacetylene or oxyfuel. For milling, the software can support drill cycles, tool change option. I don't use it, I just activated the trial just to see how it works on my bench. Automatic spindle speed overriding, that can be done. Rotary index machining, it's the Exes, so you need this one. 5-axis machining, index machining, and classical 5-axis machining. Turning module is still not here. 3D printing in development. Laser cutting is in development. Next one. Background operations. That is something very interesting. That is kind of a macro which is constantly running in the background and, let's say, monitoring some of your inputs even when you don't run the G-code. That's something for the advanced users also. Modbus settings. Well, this version of software can communicate over the Modbus. Some of the VFDs can communicate over the Modbus, so you can send the commands to your VFD, start spindle, stop spindle, clockwise rotation, anti-clockwise rotation, set the speed, and so on and so on. So that is for the Modbus. And calibration wizard, this is something that I will have to try. If you want to start the wizard, I think you have to switch on the controller, go to the configuration, because when you switch the controller on, you can communicate with it. And you have the ability to set up the feed, speed, and the distance to travel. So I can say run, machine will run. Well, it is running at the moment. And what is the measured distance? Distance for the calibration was 100 millimeters, and I will say, okay, that's 100 millimeters. Apply new settings. Nothing has changed, as you can see. But if I change the belt, or if I move the controller to another machine which use the lead screws or the rack and pinion, this is the way to calibrate your axes, X, Y, and Z, or how many axes you have. All axes can be activated this way. Plugins, plugin configuration. Here you can activate or deactivate the CNC pendants. I don't use the pendant. And you can check online for the updates, tech support request, and about will tell you which version of the software is. You have the sites where you can go and check many of the things. So guys, thank you for watching. Maybe there will be some more videos. And when you switch it off, you have two options: to shut down client and server, or just the client. Only client is the software. I just switch both of them off. That's it. Thank you for watching.